Hi, a quick video here. This is Tim, if you didn't figure that out already. Quick video here. I'm going to try and do the alignment with tools on hand of the S meter. So the instructions they give you don't really give you much of a starting point, because there's three related potentiometers to adjust inside. One is the 0 set. That one's pretty much given. The other one would be the S1 level, and the other one's the S9 level. So the meter set I've already taken care of. It's sitting at the 0 with no signal applied. So I'm going to show you how I calculated the rest. Alright, what you're looking at is the potentiometers for setting it. VR3 here would set the 0 set. VR4 over here sets the S9 level, and then if you zoom across the board right here to VR1, I'm pointing at right there, that sets the S1 level. S1's also the sensitivity level. I guess you could say that's the point where it gets butt off 0 and makes it to start work. So what I did was, we're going to zoom around to the other signal generator. So I have the signal generator set at 14.2 megahertz non-modulated signal, and the lowest that goes, well, that I can work with, it goes to 0.7 millivolt RMS, which is nowhere near enough to be a minus 73 dB signal, dBm signal. So what I did was I looked up on something called the internet, where what the voltage and dB ratio was for the signal that I could get closest to. So 1.6 millivolts I found on the net at a website, GIANGRANDI. I don't know if it's giantgrandi.org. Anyhow, pretty good site. I just did a search on how many dB is an S1 signal, and it came up. This was one of the sites that came up, and they have a real nice table outlined here. So let's see. Anyhow, what I found was at 1.6 millivolts RMS, that is an S9 plus 30 dB. So, that being said, if I turn my meter or my radio on with that signal, I should get an S9 plus 30. So we'll try that out in a minute. I'm going to show you one more thing that's going to come into play here. That doodad right there, I got it's from an old maybe Popular Electronics or something. I'll have to actually see, but it's basically just a kind of like a voltage divider circuit, but it's calibrated for decibels, and it works pretty good. I mean, it is what it is, but I can choose the drop I want all the way up to 80 dB. So right now we're leaving it with no dropout whatsoever, 1.6, and we're going to go back and look at the radio when I turn it on. Okay, so there's the S meter on 14.2 megahertz. Now I'm going to turn my output signal on. I'll make sure I have no attenuation in here. And if you look, it's almost exactly the S9, and it's halfway between plus 20 and plus 40, which makes it plus 30. So far so good. The radio comes in with a 10, 20, or 30 dB attenuator. So theoretically, when I switch this to minus 30 dB, I should get the S9, because we already know that my function generator doesn't go low enough. It goes 30 dB over S9. So I'm going to attenuate 30 dB out and see what happens. Using the meter or the radio's attenuator, I took out 30. It's a slight bit over S9, but it's S9 pretty much. So far that works. So now, using the handy dandy relationship data that they post on that website, to get an S1 signal, I need to add 48 more dB, because basically an S9 is 0 dB, and if I can add, or basically subtract 48 more dB, or add 48 dB into my line, I should get an S1. So let me go over here and flip some switches on that meter, or that little box I showed you. There's 20 dB. There's 40 dB. So we're a little bit over an S1. And what did I say? 48. There's 45. Still a wee little bit over S1. And there's 48, and that goes S1 exactly. Now, I did adjust this just before. I wanted to confirm that it was going to work before I tried all my math calculations. So basically, with a 1.6 millivolt signal at 50 ohms, and adding in 30 plus 40, what did I get? 20, 40... 30 plus 40, that's 78 dB. So by adding in 78 dB, I should get an S1 signal. So that's it, and just something I thought I'd show you. What else was I going to tell you? Oh, it works. Like I said, the meter's a little bit sluggish and slow, but it does work even on 28 megahertz and on 14, where it was the lowest of the two. But adjustment like this brought the S1 up a little bit higher, gives it basically a higher starting point, so it doesn't seem like the meter is completely dead. Radio receives fine. It works as far as the S meter goes on 14 and 7. I've checked it out. I compared it against the TS 590, and if you don't have the preamp on, the signal strength is pretty much equivalent to the same thing as it is on this. So I guess it just must be getting used to a sluggish meter on certain bands. Okay, just wanted to show you this 940 in action. There it is with 14.2 megahertz. Really good needle movement. I'd say that sounds like probably an S9. To my untrained ear, it sounds like an S9. So that's it working. So there's something else I wanted to show. Let me move this over here. Let me pause this. Alright, so this is on same frequency, 14228 in CW with I'll just show you. This is to indicate those new the new drivers that I put in. CW, it's going into a dummy load, but you can see there it's a 0 to 100 0 to 100, say it Tim, slug in there, and it goes up to right around 100. So that's that. On sideband, let's put it sideband, same thing. Hello, testing 1 2, hello. So looks like it does about 80, probably a little bit better than that, and the meter reflects that. That's without the processor or anything turned on. So let's see. I'll show you a different band. 28, 220. We'll go to like 28.5 or something. Just somewhere in the middle there. How about 28.4? 28.4 on CW. See what we get. Again, just about 100 right at the meter. The meter on the radio itself. I can show you that as well. That's shown just a little bit below 100. Zoom in. I can never tell how good these are going to be looking through the lens. So see, it's a little bit below 100. Same, about the same thing, and then upper sideband. Hello, hello. Between 80 and 100 with that too, so no complaints. The other thing I was thinking about for this is one of those new power supplies, the switching power supply. It's everything. They basically got out everything and put the new power supply in, and it's supposed to give you better performance and, of course, probably a little more dependable. And then it runs the cooling fans on high. But you know, in the final section of this, it never seems to get that hot. I don't talk a lot, so at least on the radio. So anyhow, that's I just wanted to show you. I knew I had mentioned earlier that if I get a chance, I'd show you how it works with the new drivers in. Like I said, it's been a couple years, no issues. All right, for real, that's all I have on this. Thanks for watching.